when a central atom is surrounded by two electron pairs, then the shape will be linear and the bond angle will be 180. When one atom is surrounded by three bond pair and one lone pair, this shape is called trigonal pyramidal shape. Today in this lesson, I will explain the valence shell electron pair repulsion theory, or we can also, in short, we call Vesper theory. So Vesper theory is the theory that is used to predict the shape of the molecules from the electron pairs that surround the central atoms of the molecules. According to this theory, I will discuss the five cases, or I will show you the five shape that are the most common. Number one, the linear shape. Number two, trigonal planar. Number three, bent shape. Number four, tetrahedral. And number five, trigonal pyramidal shape. Basically, I will discuss these most common shape, and with the help of when you are able to understand these shapes, then you will have a very good concept of Vesper theory. Let's start with the postulate first. The postulate of Vesper theory. Number one postulate is that the quantity of valence electron pairs, the bond pairs or the lone pair surrounding the core atom, determine the structure of the molecule. So this is the key postulate. Basically, because of the bond pair or lone pair that surround the central atom, make the geometry. Okay. The second postulate, because their electron clouds are negatively charged, pair of electron in the outermost shell repel one another and locate their self at maximum distance. Okay, as earlier I told you, there are two types of electron pair, bond pair or lone pair, and both are made up of electrons, so they will repel each other. When they will repel each other and they try to locate their self at the maximum distance, and when they locate their self, then the geometry appears. Okay, now let me talk about the how they repel each other. The repulsion order. Basically, the lone pair repulsive forces are the greatest, and the second is lone pair bond pair, and the least is bond pair. The multiple bonds are viewed as single electron pair, and their two or three electron pair are handled as single super pair. Okay, remember that in covalent bonding we have double bond, triple bond. So we will consider double bond or triple bond as a single electron pair, and these are the common Vesper postulate uh, that I have just shown you. Now let's talk about the 3D shape of the molecules. Okay, the first case, one when a central atom is surrounded by two electron pairs, or we can also call it as two atoms, then the shape will be linear and the bond angle will be 180. So so this is the three-dimensional shape. Now you can clearly see. So if I try to bring this electron pair near to this one, so it what it will do, as it has a repulsive force, so it will make itself as far as possible and arrange itself at 180 degree. Okay, let me show you the real model, the real shape. So real shape example is carbon dioxide. In the carbon dioxide, carbon and oxygen atom has double bonds. So according to the theory, the multiple bond will be considered as a single. Now you can see the angle is 180 and the shape is the linear. Okay, now let's talk about the next case. The second case is when one atom is surrounded by three bond pairs. So what will be the shape? The shape will be trigonal pyramidal and the angle will be 120. The angle will be 120 when the all the atoms are same, because they will exert a same force. Okay, the real example is BF3. Let me show you the real example. Okay, this is the real example of trigonal planar shape. You can clearly see the angle is 120 and the shape name is trigonal planar. Third case, when one atom is surrounded by one, two, three, four bond pairs. So what could be the shape? The shape will be tetrahedral, and the bond angle between the bonds will be 109.5, and every bond angle will be the same because it is surrounded by four identical atoms. Real example is CH4. In CH4, one carbon atom is surrounded by four identical hydrogen, so the bond angle will be 109 and shape will be tetrahedral. In the last three example, I have shown only the model having bond pairs. Now I will show you the model having a lone pair. So this is the case number 4, in which one atom is surrounded by two bond pairs and one lone pair. So this is the model, simple model. Now you can clearly see uh, the shape will be band shape. So this is called the band shape. We do not consider this lone pair in the shape, so we only focus on the atoms. So according to the atom geometry, the geometry is bent, and as it is surrounded by three electron pair, the bond angle should be 120, but it is not 120. How the let me give you the reason with the real example. Let's suppose this is the real example of SO2, sulfur dioxide molecule. In sulfur dioxide molecule, you can clearly see the shape is bend shape because of this lone pair, but the angle is less than 120. Why the angle is less than 120? If you do remember in the postulate that the bond lone pair, sorry, the lone pair exert more force. So when it exerts more force from in the three-dimensional space, so bond angle reduces and it become less than 120. In the case of SO2, we are seeing that the bond angle is 119. So it could be different for different models, but right now one thing will be the same, that the it will be less than 120 because of this one lone pair. Okay, now move toward the another case. Okay, this is the second last case, when one atom is surrounded by three bond pair and one lone pair. Okay, now this is the shape. Yes, yes, this is the shape. This shape is called trigonal pyramidal shape. According to the electron geometry, as it is surrounded by four electron pairs, so the bond angle should be 109.5. So if you do remember in the previous example, I already shown you that the bond angle should be less than as the electron geometry. The reason because of the presence of this lone pair. Okay, let me clarify this thing with the help of a real example. Okay, now this is the real example. This is the real example of NH3 ammonia. The molecular geometry is trigonal pyramidal and angle is 107.8. Or in this example, you can clearly see that it is not 109.5, it is less than 109 point. If you do remember, because of this one lone pair, the bond pair reduces. Okay, now let's talk about the last example of this lesson. When one atom is surrounded by two bond pairs and two lone pair, so what could be the shape? Shape will be bend shape, and the angle should be less than 109. Why I'm saying this is less than 109? The reason is that according to the electron geometry, it has four electron pair. So four electron pairs should have the bond angle 109, but it is not 109 because of two lone pairs. Let me show you with the help of real example. Now this one is the real example of water. In the water have a bend shape having two bond pair and two lone pair. As these lone pair exert a very huge repulsive force as compared to bond pair, So the bond angle reduces and it becomes 104.5. Thank you, class. If you do have any question, you can ask me this question in comments.